Every unique planet in the solar system has a different atmosphere. So let's start talking about our Earth's atmosphere. The atmosphere, of course, is the layer of gas that surrounds our planet. It is about 80 miles thick. If you hear about space probes or individuals who are Elon Musk and people who are flying their own spaceships out of the Earth's atmosphere, that means they have to get at least 80 miles above the surface of the Earth. So we are cocooned in this beautiful layer of gas all the way around our planet. And our atmosphere is made up of mostly nitrogen, about 78% nitrogen, about 21% oxygen, about 1% argon, and then trace amounts of everything else. Carbon dioxide, which you and I exhale, water vapor, and all the other gases you've ever heard of. Helium, hydrogen, krypton, xenon, all the other gases that you've ever heard of make up these trace tiny amounts. Now, nitrogen, the most abundant element in our atmosphere, is inert. And what that means is it has very few chemical reactions. So when you actually breathe in or breathe out lots and lots of nitrogen, it usually just kind of goes in and it comes back out of your lungs, and it does not chemically react with your body. Oxygen, of course, is what is essential for life, for you and me and other animals. Now, this 80-mile thick layer of atmosphere produces something which is called atmospheric pressure. Now, this atmospheric pressure is the weight of the air holding us down or pushing down on us. What it is called when all of the weight of the air is pushing down on us, like you and I are sitting on the bottom of the ocean, but it's an ocean of air, that is referred to as one atmosphere, which is kind of a generic term of what's typical on planet Earth. You may have heard the concept of 14.7 pounds per square inch. That's another way of measuring atmospheric pressure. Some planets have crushingly huge atmospheric pressures, and some other planets have very light atmospheric pressures. But one atmosphere, 14.7 pounds per square inch, those are two numbers that you may hear again. Now, there's a thing called the greenhouse effect, and if you've been paying attention to the news throughout your life, you know that the greenhouse effect is what makes the heat that enters the sun stay next to the planet. If we did not have any atmosphere, and if we did not have any carbon dioxide in our atmosphere, our planet would be very, very, very cold, and it would be a big ball of snow or ice. But we have enough atmosphere and enough carbon dioxide that just like a cute little glass greenhouse that is growing plants, the sunlight comes in and then the heat stays in and does not radiate back out. And that's why people put plants into greenhouses. One, they need the light, but two, it actually amplifies or increases the quantity of heat. Well, this is very important, and it is really a good thing. The challenge is if we have too much CO2, if there's too much of it, you end up with what is called a runaway greenhouse effect. And that means that more heat stays in than comes out, and the planet keeps getting hotter and hotter and hotter and hotter and hotter. That is what has occurred on planets like Venus. And this is what many people are concerned about, because the product of combustion, you burn anything from you have a bonfire in the backyard to burning fuel like gasoline, oil, or diesel fuel. The product of combustions, one of them is carbon dioxide. And so that's that fear on planet Earth that as we add more CO2 to our atmosphere, the heat, and some heat is always trying to escape back into space. If we hold more and more of it, our planet will keep getting warmer and warmer and warmer, and that will affect our climate. That will do for the Earth's atmosphere, and we will next time talk about tides.